for BPSK we'll discuss in this particular class, and a small this one quiz is there at the end of the class for 5 minutes. You can answer to that and you can take the off for the error afterwards. Okay, now when you go for a probability of error, so what is expected for an BPSK, the probability of error? Because as per the discussions we made in the earlier classes, the probability of error for any digital system after the modulation, it should be kept as minimum as possible. So for that BPSK, when you have considered this BPSK, how to construct a signal space diagram and how many basis functions we'll have, how many symbols you will have, how to convert that symbol into line coding, and for that line coding, how many basis functions you require, you have decided and you have uh, defined the transmitter block, receiver block, everything. Now, if you are considering the signal space diagram, so this signal space diagram will be the representation of your signal with the basis function. Whenever you go for your signal in BPSK, you have how many signals? Two signals. One is S1 of t and the other one is S2 of t. When you go for this S1 of t, because we are considering bipolar coding technique, S1 of t is represented as root EB into phi 1 of t. Similarly, when you consider this S2 of t minus root EB into phi 1 of t, these are the two signals we are going to transmit in the BPSK using bipolar coding. When these S1 of t and S2 of t and these signals, when we are representing in the signal space diagram, you will be representing the first signal S1 of t having an amplitude of root EB, and another signal S2 of t is having a amplitude of minus root EB. And the again is the basis function. Since we are constructing, how many basis functions we have? Only one function, that is phi 1. When this root EB is the amplitude, the region for some threshold we have decided at the decision device, that threshold voltage for the decision device we decided as 0, because that will be an average of two signals amplitudes. When it is average taken, it is going to be 0 as the threshold level. So this threshold, with reference to this, if you are representing the finding the region for signal 1, so the region Z1, it is lying from 0 to towards plus infinity, and if you go for the region Z2, that is where the signal S2 it is placed. So this region Z2, 1 minute. Region Z2 will be the region where the signal S2 of t will be estimated. Okay, so this is what the signal space diagram already we have seen in the previous class. And if you are considering the receiver, consider the receiver structure. If the receiver structure you are observing, because from the transmit signal space diagram and from the receiver structure, we are going to define the probability of error. So you will have the x of t. This x of t may be S1 of t or S2 of t, that will be received when it is received at the receiver through the channel will be received at the receiver. It will be subjected to an correlator. Correlator will have the multiplier and it will have an integrator. So this integrator, it is 0 to TB with respect to dt. So along with this integrator, you will be providing the output of this integrator will be what? It is a signal vector x1. It will be given to an decision device. So this decision device will take a decision based on whether symbol 1 has been transmitted or symbol 0 has been transmitted. What is the decision? 1 when it will be decided and 0 when it will be decided if x1, this is the decision device with respect to threshold will be there. So whenever the threshold value above this x1, if x1 is greater than 0, then symbol 1 will be decided, and if x1 is lesser than 0, symbol 0 will be decided. That is what the, and if you are taking this complete correlator, it is including the multiplier with integrator, it is termed to be the correlator. Okay, with this is an detection system, detection of BPSK system. BPSK signal from the modulation we will be using. Now, from this information, let us continue for deriving the probability of error. So this probability of error, when you start deriving it, let us take first what will be the transmitted signal. Let x1 be the received signal. So this x1, when it is received as the received signal, x1 of t or whatever it is, so x of t, how it will be means, it may be s1 of t in general. In general, the received signal may be due to the symbol 0 or symbol 1 transmission. So therefore, your received signal in general, we can write it as x of t as equal to s of t with w of t. You can call this as equation number 1. Where this w of t, what is that where w of t? W of t is the, yes, what is w of t?
White Gaussian noise.
White Gaussian noise with properties what? 0 mean?
N0 by 2 p.
Yeah, PSD is equal to power spectral density is equal to N0 by 2, or the variance as N0 by 2, right? So now with this, if we are moving, your x of t, here x of t may be, x of t, it can be either of the two symbols. It may be s1 of t or it may be s2 of t. When s1 of t, when s1 of t will be received as x1 of t, when transmitted signal is symbol 1. So how do you represent this s1 of t in terms of basis function? So root of eb into phi 1 of t. So similarly, s2 of t we are representing as minus root eb into phi 1 of t. This is for symbol 1 and this is for symbol 0. Okay. Now let us assume, moving forward, let us assume that symbol 1 has been transmitted or symbol 0 is transmitted. Symbol 0 is transmitted. Then the output of correlator. How do you write? Then output of correlator, how can we write? Yes, students. From this diagram, how do you represent from the correlator the output? Output of correlator is x1, that is equal to. Can you tell me the expression? Correlator consists of which are the two blocks from this diagram?
Multiplier and integrator.
Yeah. Now, how can I write this x1?
Integration from 0 to t.
Yeah. Okay.
Minus square
Now,
root of b phi 1 of t.
so you can write here as x of t. In general, we have this expression, right? In general, what is the x1? x1 is like this. Now, when x of t you are considering, what is the symbol x of t is now? When 0 is transmitted? When 0 is transmitted, what is your x of t? Students, what is your x of t? Hey, symbol 0 you are transmitting. How do you transmit the symbol 0? How are you transmitting? So therefore, your x1, it is equal to integral from 0 to tb s2 of t. So let me write that s2 of t and split that complete function into phi 1 of t into dt. This is first term plus integration from 0 to tb in place of along with the signal there is a noise also which is getting added, that is represented as w of t into phi 1 of t into dt. Okay. Further simplifying this expression, x1 is equal to integral from 0 to tb. What is your s2? S2, how do you represent S2 from this expression? Students, you are not there in the class or you are there? Plus okay, now if I am writing, if x1 is further simplified, can you tell me what is your x1 further if after simplification? Zero to tb minus root eb into phi 1 square of t into dt plus integral from 0 to tb w of t phi 1 of t into dt. So if further it is simplified, this whole thing, what is phi 1 square of t value? Unit energy of an basis function, what is its value equal to? this value will be equal to 1 and this value will be equal to whole thing W1. So therefore, if you are rearranging this expression, x1 as equal to integral from 0 to TB root of EB into dt, okay, plus W1, which is equal to a constant integration. It is root EB into TB. So therefore, that TB, if we normalize, it is equal to minus root EB plus W1 is the x1 value. Okay. Now, since we need to find out the probability of error function for the BPSK signal, we have to, for that probability of error to compute, first we need to compute the mean and the variance of S1 of t. So mean of random variable x1, mean of random variable x1, how can you compute? Is given by mean. I'll be representing with this mu. Mu, that is equal to the mean value, estimated value of x1, which is equal to, what is x1? The received vector. It is minus root EB plus W1. Okay. This is equal to expected value of minus root EB plus the estimation of W1. Okay. So what is the mean value of this is equal to mean. Mean of noise is what? Mean of noise or additive white Gaussian noise. What's the value? Equal to 0. So therefore, a mean value of an constant, always it is given as constant. So therefore, the mean value when you are taking for an random variable x1, it is equal to minus root EB. Similarly, compute variance. Variance, it is represented as sigma square. So this variance to compute, so variance of x1 you need to compute. So how we can calculate this? It is equal to variance of, okay, minus root EB. X1 we have to compute, no? X1 value already we have computed for symbol 0 transmission as minus root EB with W1. So what is the variance of a constant? So here variance of this, you can write it as variance of x1, it is equal to, okay, variance of minus root EB plus variance of the noise W1. If you are computing a variance of any constant, because this whole thing, it is a constant, okay, constant. If you are taking a variance to a constant, that is equal to 0 plus variance of noise, it is equal to n0 by 2. That is what the complete variance. So therefore, a random vector or random variable x1 whose variance it is given as n0 by 2. Now, once you have computed the variance and the mean value of the transmitted symbol, received symbol, you take, transmitted symbol 0. Now, conditional probability density function, how do we compute? Conditional power spectral probability density function when, which is the symbol that has been transmitted? Symbol 0 is transmitted. Given by f of x1, that is the received vector x1, random variable. When x1 it is received for the transmitted symbol 0, 0 is transmitted, x1 has been as a random variable we have received. It can be computed as in terms of variance and mean value. How it has been given means root 2 pi sigma square 1 upon, multiply this with minus x minus mu whole square divided by 2 sigma square. You can call this as equation 2. Okay. What is mean value of x1? But we know that mean of random variable x1. What is the mean value? Which is represented as mu, which is equal to minus root EB, and variance value of x1, this you can see, and variance value of x1, it is represented as sigma square, it is equal to n0 by 2. So therefore, if you are substituting these values to the above expression, it is equal to f, the probability density function, conditional probability density function for a random variable x1 received by transmitting symbol 0, you can rewrite as equal to 1 by root of 2 pi. What is your sigma square? It is n0 by 2. Multiply this with e to the power of minus of x, I'll retain as it is. What is your mu? It is mu is minus root EB. So therefore plus root EB whole square divided by this 2 into sigma square, that is n0 by 2. This 2, you can cancel it out. This and this will go. So therefore f of x1 with 0 transmission and we received as x1, it is equal to 1 by root pi n0. Multiply this with e to the power of minus of x plus root EB whole square divided by n0. Or you can rewrite this as 1 by root of pi n0. Okay. E to the power of minus x plus root EB divided by root EB whole square. Can I write in this way? Can I write in that way? let probability of error for 0, P of 0, let us consider as denotes the conditional probability of decoding PE of 0 decoding in favor of symbol 1. Please observe carefully here. What is the transmitted signal? What is the transmitted symbol? Students, are you there? When symbol 0 transmitted. Are you there? Students, you are there, right?
Yes, ma'am.
Okay. I don't know whether if you don't respond, I'll get a confusion that you are not there. Okay. Next, if you go for this probability of PE of 0 is the probability of error, conditional probability of error for deciding in favor of symbol 1 when 0 is transmitted. So whenever symbol 0 is transmitted, as per signal space diagram, as per signal space diagram, where the symbol, which is the region that is going to be considered for symbol 1? We'll be considering region Z1. So symbol 0 is transmitted, but symbol 1 is going to be estimated. Then its probability of function, probability density, probability function, it is represented as PE of 0. Since this PE of 0 for the transmitted symbol 0 estimated as symbol 1, then the complete function or the observation vector, it is going to lie between 0 to infinity in the region X, in the region Z1. So which is represented as f of x1 when 0 is transmitted and received as the observation vector x1. Integrate with respect to dx1. So what is your f of f x1 of x1 comma slash 0? It's already we have proved that it is root of pi n0 from equation 3. I'm rewriting this. So from x1 as equal to 0 to infinity, because that is in region Z1. Okay. So this will be equal to e to the power of minus x1 plus root EB divided by root of n0 into dx or yeah dx. Now here put z is equal to x1 plus root eb by root n0. Okay, here lower limit what it will happen when x1 is substituted as 0 at x1 is equal to 0. What is this value? Z value will be equal to z is equal to root of eb by n naught, and upper limit with z x1 as equal to infinity. So during that time, what is z is equal to infinity itself. Okay. Now you have to find out the dx. dx1 by dz. It is equal to what? Root of n0 1 by, so dx1 by dz. So dx1, when we are calculating dz into root of n naught, we'll be getting as the upper limit. So hence, if I replace your PE of 0 root of EB by N0 infinity, lower limit, upper limit I have added, 1 by root pi N0 into e to the power of minus z square into root N0 into dz. Okay, so this further you can simplify this root n0. If it is going, what will be the final solution that you will have? It is equal to this root n0, this root n0. Both will get cancelled, or you can rewrite this as root of eb by n naught infinity 1 by root pi into root n naught e to the power of minus z square into root n naught into dz. So this and this will go, and you will be left out with 1 by root pi integral from z to infinity e to the power of minus z square into dz. Can call this as equation number 4. So I think I can stop at this point, and I will give you 5 minutes this one quiz, and then I'll close the class.